अब यसमा चाहिँ तिमीहरूको जुन सेप्टिक ट्याङ्क र सोकपिट हुन्छ जुन सेनिटरीमा पढाएको थियो ठिक छ। अब त्यसको चाहिँ अब एस्टिमेट कसरी गर्ने के गर्ने भन्ने कुरा हेरौँ है त। तिमीहरूलाई एक्जाममा त्यही फिगर चाहिँ यसरी दिएको हुन्छ है, तिमीहरूको क्रस सेक्सन र टप भ्यू भनेर यसरी चाहिँ दिएको हुन्छ है।
सर रेकर्डिङ स्टार्ट गरिदिनु न।
गरेको छ, भइरहेछ रेकर्डिङ।
हस् सर।
त्यो सबै कुरा त्यही यहाँ ड्रइङमा जे छ त्यही कुरालाई बनाएको है। यहाँ हाम्रो बेसमा यसरी स्लोप भइहाल्यो ठिक छ, हाम्रो सेटलमेन्ट यतातिर होस् भनेर। अनि यतातिर सोकपिट, यतातिर आउटलेटबाट के गर्छ हाम्रो सोकपिटमा जान्छ जुन, ठिक छ। माथिको तलको सबै यो ड्रइङ अनुसार हाम्रो क्वेसन एक्जाममा जुन दिएको छ त्यही अनुसारको चाहिँ यो हाम्रो 3D को यो एनिमेसन ड्रइङ बनाएको छ है।
सर अस्तिको पायर फाउन्डेसन सकेको हो र?
हजुर
अस्तिको त्यो पायर फाउन्डेसन सकेको हो र त्यो अस्ति गरेको?
ए पायरको अलिकति बाँकी थियो लास्टको।
हजुर सर।
कहाँसम्म भएको थियो?
त्यो स्प्रिङिङ लेभल पनि भएको थिएन सर पहिला, अझै अगाडि हो।
यहाँसम्म त भएको थियो। ठ्याक्कै यो सकेपछि मैले पज गरेँ जस्तो लाग्छ। यो माथिको ब्रिकवर्कको पोर्सनको पनि भएको होइन र? यहाँको र यहाँको दुईटाको एभरेज लिनुपर्छ भनेर यो हाम्रो यसरी इन्क्लाइन भएको भएर।
नै सर म पहिलाको रेकर्डिङ हेर्छु।
त्यो पनि त्यस्तो गाह्रो छैन, त्यही सिमिलर पोर्सन नै हो। ठिक छ, यो बिचको साइडको र यो ट्रायङ्गुलर पोर्सन कटिङ पोर्सन तिनटाको गरेको त हो। कटिङ पोर्सनमा चाहिँ त्यही ट्रायङ्गल छ, ट्रायङ्गलको एरिया इन्टु हाइट गर्नु पर्यो। त्यही यो हाम्रो एरिया ट्रायङ्गलको एरिया भइहाल्यो। जति फर्स्ट फुटिङमा विथ बढी थियो, माथि हुँदा कम कम भइरहेको थियो, त्यही भएर त्यही अनुसारले विथ राखेर हाम्रो एरिया त निकालिहाल्यो। ठिक छ, अब यो अप टु स्प्रिङिङ लेभल भनेको चाहिँ स्प्रिङिङ लेभल भनेको त्यही हाम्रो सपोर्ट लेभल जुन थियो खै त, यो हाम्रो यहाँ माथिदेखि लिएर अनि माथि बल्ल हाम्रो के थियो कल्भर्ट थियो नि। ठिक छ, भनेपछि यहाँ तलदेखि यहाँ माथि स्प्रिङिङ भनेको यहाँ सपोर्ट जुन दिएको छ। ठिक छ, यो पाहाडले यो बेसदेखि यहाँसम्मको मेरो यतिको ब्रिकवर्कको चाहिँ एस्टिमेट गरेको हो। त्यही भएर त्यसको लागि चाहिँ त्यही अनुसारको हाइट राख्नु पर्यो। यो यसको ट्रायङ्गलको एरिया निकाल्न त सकिहाल्यो। त्यो ट्रायङ्गलको यो ट्रायङ्गलको एरिया लिएको इन्टु त्यसको हाइट गरेको त हो। अब त्यो 1.2 कसरी आयो भन्दाखेरि त्यही तल यहाँ बेसमा हाम्रो 150 छ, यहाँ माथि कति छ 90 छ भनेपछि यो हाम्रो त के छ, यो अलिकति इन्क्लाइन छ भनेपछि दुईटाको एभरेज लिनु पऱ्यो नि। एभरेज लिएर भनेपछि हाम्रो 0.12 आएर त्यही अनुसारले त्यो बिचको पोर्सनको चाहिँ हाम्रो एरिया निकालेर अनि टोटल हाइट कति छ 3.6 मिटर छ भने चाहिँ 3.6 ले मल्टिप्लाई गरेर त्यसको क्वान्टिटी आएको हो।
सर साउन्ड आएको छैन।
एहे,
calculate, we will get the total.
अहिले आइरहेछ हैन?
आछ सर, आछ अहिले आछ।
Quantity 2.25 cubic meter. Our next step is to calculate the estimation of the cement concrete at the upper part of the ends of the pier. That means here we can see that above the springing level we have this small quarter of this sphere portion at this side of the pier. So at the east water end we need to do the cement concrete on this side. We have to use the formula for the volume of the sphere and divided it by 4 to get the quarter of the sphere. So we already know that the volume of the sphere equals to 4 by 3 pi r cube, but we need to calculate the radius. That means this radius will be this total width by 2. That is, the small portion would be 90 centimeter by 2. So we can say that the radius equals to 90 by 2. And we have the volume of the quarter of the sphere equals to 4 by 3 pi into r cube, where r is the radius, and since it is a quarter of the sphere, we have to divide it by 4. So we can write that the radius equals to 0.9 by 2. Since the total diameter equals to 90 centimeter and the radius would be 90 by 2. So we can write that the radius equals to 0.9 by 2, and we have to put the value in this formula. So we have 4 by 3 into pi into r, that is 0.9 by 2, and then cube of the radius, and we have to multiply it by 1 by 4. So we have already calculated the volume of this portion. Next is our cut water end portion. That means In this cut water in portion, we can see there is a triangular pyramid portion. So we can use the direct formula of this triangular pyramid. That is, volume of this triangular pyramid equals to 1 by 3 area of the base triangle into height. So firstly, we need to calculate the area of the base triangle. So here, this is the cut in portion, and we need to calculate the base area, that means this portion, and we should multiply.
आइसमा हमारा रहने
टॉपिक चेंज करना कोई किरण हवा से सीखो
आइसमा हमारा रचार पूरे शहर में दे तो हम
सर
So for to calculate.
यो हाम्रो इक्जाममा प्रोभाइड गर्ने फियरमा चाहिँ कता छ नि त्यो स्फियर छ ट्रापेजोइडल भन्ने कसरी हेर्ने हो त एक्चुअली हामी प्रोभाइड गरेको फियरमा चाहिँ
Portion. So we can use cut water of this portion. Right? Or we can write that the radius equals to square root radius per on this 4 to get the
अब तिमीलाई फिगरमा एक्जाम चाहिँ यसरी दिएको एक्जाममा चाहिँ फिगर चाहिँ यसरी दिएको हुन्छ ठीक छ
हजुर सर
अब यो तिमीहरूको यो यताको कटिङ पोर्सन भयो यताको हाम्रो त्यही कर्भ पोर्सन भयो ठीक छ अब यो कर्भ पोर्सनमा चाहिँ त्यहाँ त्यही हाम्रो सर्कुलर बन्नु भएर यहाँ त्यसको माथिको सर्कुलर पोर्सनै भएको हो यहाँ कटिङ पोर्सनको माथि चाहिँ हाम्रो यहाँ पिरामिडै बनिएको है अब यो फिगरमा अलिकति अर्कै देखिया छ
त्यसलाई पिरामिडै मानेर गर्ने हो सर यो
पिरामिडै मानेर गर्ने हो
यता त उस्तो जस्तो देखियो दुईटा हैन
त्यही त यसमा नि त्यही कर्भ नै जस्तो देखिरहेको छ अब त्यही त यतातिर ट्रायङ्गुलर पोर्सन हुन्छ नि त हाम्रो टप भ्यूमा हेर्दाखेरि त ल पक्का यता कति भयो
the way. In our question, we have this sectional elevation. Firstly, level of detail. Today, we are going to do the detail estimation of upward way. And here is up arcs of the. This is.
ठ्याक्कै यहाँ हेर है त यहाँ यो फिगरमा चाहिँ मजाले देखिन्छ यहाँ के हुन्छ हाम्रो बेस त के हुन्छ यहाँ ट्रायङ्गल हुन्छ अनि ट्रायङ्गलबाट यहाँ सर्टेन हाइटमाथि निक्लेको हो नि त त्यो स्प्रिङिङ लेभलमा ठिक छ अनि यहाँ इजबाट पोर्सनमा के छ यसरी कर्भ बनेको छ त्यो कर्भ नै माथि उठेको हो नि त त्यही भएर यतापट्टि पोर्सनमा के हुन्छ भन्दाखेरि हाम्रो स्फेरिकल पोर्सन हुने भयो यतापट्टि पोर्सनमा चाहिँ हाम्रो ट्रायङ्गुलर पोर्सन हुने भयो है
हुन्छ सर यो टप भ्यूबाट बल्ल क्लियर भयो
We have the volume of the radius, and so we can enter equals to 90 centimeter, and the radius would be 90 by 2. So we can write that the radius equals to 0.9 by 2, and we have to put the value in this formula. So we have 4 by 3 into pi into r, that is 0.9 by 2, and then cube of the radius, and we have to multiply it by 1 by 4. So we have already calculated the volume of this portion. Next is our cut water end portion. That means in this cut water end portion, we can see there is a triangular pyramid portion. So we can use the direct formula of this triangular pyramid. That is, volume of this triangular pyramid equals to 1 by 3 into area of the base triangle into height. So firstly, we need to calculate the area of the base triangle. So here, this is the cut end portion, and we need to calculate the base area, that means this portion, and we should multiply by the height. So firstly, we need to calculate the area of this base triangle, and we have the area of the triangle 1 by 2, and base is this portion, and height will be this height of the triangle. Width of the pier is 90 centimeter at its top portion, and this portion is 45, that is 90 by 2, and this portion is also 45, that is 90 by 2, since this is the midpoint. And we have this angle 90 degree. We can use the trigonometric relationship of tan to find this length. So we can write tan 30 equals to p by b, in which our perpendicular height is this portion, that is 45 centimeter, and this portion is unknown portion. So we can write as it is, that is b. So we will get the b equals to 45 by tan 30, so we can get the value of the b equals to 77.9 centimeter, or in terms of meter, we get 0.779 meter. Now we can easily use the formula for the area of the triangle. So we have the area of the triangle equals to 1 by 2 base into height, in which our base of the triangle is this total base. So this base equals to 90 centimeter or 0.9 meter, and the height of the triangle is this portion, that is 0.779 meter. So height equals to 0.779 meter and we get 0.35 meter. So now we have to put the value of this area of the base in this formula. So here we have this total width of this pier 90 centimeter. That means the diameter equals to 90 centimeter and this portion is the radius. So radius equals to 90 by 2 or 0.9 by 2 meter, and we know that the radius are equal. So this portion is also the radius and this height is also the radius. So we can easily write the height equals to 0.9 meter by 2. So the height equals to 0.9 by 2. So I can write the volume equals to 1 by 3 into area of the base equals to 0.35. So here 0.35 and the height is 0.9 by 2. So we will obtain 0.052 cubic meter. Now
यहाँ त्यो हाम्रो पिरामिडको हाइट माथि कतिसम्म गएको थियो भनेर फिगरमा चाहिँ देखाएको थिएन, तर कसरी निकालेको त बुझ्यो नि हैन। हाम्रो यतापट्टि स्क्वायरको जति हाइट हुन्छ उतापट्टि हाम्रो ट्रायंगलको पनि। ठीक छ, अब यतापट्टि यो यतापट्टि स्क्वायरको पोर्सनको हाइट जति हुन्छ यो ट्रायंगलको पोर्सन पनि त्यति नै हाइट हुन्छ। एउटै लेभल मिलाउनु त परिहाल्यो भनेपछि यो स्क्वायरको हाइट निकाल्न के छ हेर त, हाम्रो स्क्वायरको त रेडियस एउटै हुन्छ भनेपछि हाम्रो यतातिरको रेडियस जति भयो हाम्रो हाइटतिर पनि कति हुने भयो, रेडियस त्यति नै हुने भयो भनेपछि हाम्रो ट्रायंगलको पिरामिडको पनि हाइट त्यति नै हो भनेर देखाएको हो है।
so I can write the volume equals to 1 by 3 into area of the base equals to 0.35. So here 0.35 and the height is 0.9 by 2. So we will obtain 0.052 cubic meter. Now our last step is the cement pointing in the exposed surface. That means we are going to do the cement pointing on all these sides and this side. We will consider them into three topics, that is, this is our rectangular portion and we will consider it as our pier portion, and this is our triangular portion. So we will do this cement pointing as our cut water end portion here, and this is our semicircular portion, so we will do it as the east water end portion. So first we will do this pier, that is the rectangular portion. So we have to do the cement pointing on this side of the pier as well as on this side of the pier. That means we have two number of this rectangular surfaces. So we can write the number equals to 2. So here we can see that this rectangular portion is of the length of 8.3 meters. So it means that this rectangular portion is of 8.3 meter length. So the total height of this pier equals to 3.6 meters. So I can write the height equals to 3.6 meter. And we know that this cement concrete is calculated in meter square. So this length into height is equals to 59.76 meter square. Now the next is our east water end portion, which is a semicircular portion. That means we are going to do the pointing on this side, that is this semicircular portion. But here we can see that we have two different diameter, that is this upper portion has a diameter of 90 centimeter and the lower portion has a diameter of 150 centimeter. So I have already told you that if we have two different diameters, then we need to take the average of these two. So we have to take the diameter as average of 90 centimeter and 150 centimeter. That would be 120 centimeter. So firstly we need to find the perimeter of semicircle, and we have the perimeter of circle pi d. So obviously the perimeter of semicircle equals to pi d by 2. Diameter equals to average of these two width. So diameter at center equals to 90 plus 150 by 2. That will be 1.2 meter.
अब त्यही हाम्रो सिमेन्ट पोइन्टिङ भनौँ या सिमेन्टको हाम्रो यो जुन प्लास्टरिङ गरिन्छ त्यो भनेको सर्फेस एरियामा गर्ने हो, त्यही भएर यसको मिटर युनिट स्क्वायर मिटरमा हुने भयो। ठीक छ, अनि सर्फेस एरियाको निकाल्नलाई हाम्रो सर्फेसको टोटल कर्भ एरिया कति छ, त्यही भएर यो कर्भ एरिया लियो इन्टु हाइट गरेपछि हाम्रो टोटल सर्फेस एरिया त आइहाल्यो है।
So we have the total area of this east water end as pi into 1.2 by 2.
यो 1.2 भनेको त हाम्रो त्यही माथि तल ठुलो माथि सानो छ, त्यही भएर बिचको एभरेज लिएर गरेको हो है।
And the height of this cut water end portion is 3.6 meter. So I can write the height equals to 3.6 meter. And lastly, our cut water end portion. That means we have this triangular portion on this side, that means this total portion, and on this side. So obviously we have this 2 number of this cut water end portion. So now we are going to do the pointing on this side and back side. So for this we need to calculate the incline length at its center, since we have 2 different incline length at top and bottom. So to calculate this incline length, we need to use the trigonometric relationship of sine, because we have this total width of 120. So here we have this width at its midpoint 1.2 meter, that is the average of 150 centimeter and 90 centimeter, and we have this angle 30 degree, and we know that this length is equals to 1.2 by 2, that is 0.6 meters. Since this is a midpoint, we have to find this length, that is this inclined portion length. So we have sine 30 equals to P by H, in which our perpendicular length is 0.6, and we have to calculate this hypotenuse. So we will get this hypotenuse 1.2 meter, that is this portion, that is our incline length is 1.2 meter. So we can write that the pointing equals to this incline length 1.2, and the height is obviously 3.6 meter, because we have to do the pointing all over this height, that is 3.6 meter. So we get 8.64 meters square, and we have this 2 number of cut water end, that is one on this side and another on this side. In this way we get 2 number of this cut water end. So in this way we have completed the detailed estimation of a pier.
पायरमा चाहिँ यति नै हो, थोरै पर्सन बाँकी थियो। केही कन्फ्युजन छ यसमा?
सर यसमा चाहिँ कङ्क्रिटको भए चाहिँ यो पोइन्टिङ हुन्थेन हैन?
कङ्क्रिटको हो भने त पोइन्टिङ भएन, त्यही ब्रिक वर्कमा त हो नि हाम्रो पोइन्टिङ गर्ने भनेको त।
हजुर
सर
हजुर
यो ट्रायंगुलर पोर्सनको एकचोटि खरेर भनिदिनु न,
लास्टको पोइन्टिङको।
हजुर
It is obviously 3.66 equals.
पोइन्टिङ गर्ने भनेको त्यही हाम्रो सर्फेसमा पोइन्टिङ गर्ने हो। यहाँ जुन यो ब्रिकहरूको यो जुन बिचमा ग्याप हुन्छ नि, यो ग्यापमा हामीले त्यही सिमेन्टको मोटारहरू लाउने त हो, ठिक छ। भनेपछि यो हामीले पोइन्टिङ गर्ने भनेको यो बाहिरको सर्फेसमा गर्नु पर्यो नि त, ठिक छ। भनेपछि यो बाहिरको सर्फेस एरिया चाहिँ निकाल्नु पर्यो है, हाम्रो यो भित्रको क्रस सेक्सन एरिया होइन कि बाहिर सर्फेसमा लाउने भएर त्यसको एरिया भनेको बाहिरको सर्फेस एरिया चाहियो, ठिक छ। अब सर्फेस एरियाको लागि त के छ हेर त्यही हामीलाई यो सर्फेस त के छ, यताबाट हेर्दाखेरि रेक्ट्याङ्गुलर, अब अलिकति ट्र्यापोजोइडल हुन्छ किनकि यहाँ तल ठुलो छ माथि सानो छ, त्यही भएर हामी के गर्छौँ बिचको मिडवाला चाहिँ एरिया लिएर गर्छौँ है। अब मिड एरिया भनेपछि हाम्रो तलको हाइट कति थियो यसको, तलको हाइट हाम्रो 150 छ, माथिको हाइट 90 छ भनेपछि ठ्याक्कै दुईटाको एभरेज गर्दाखेरि बिचमा कति आउँछ 120 आउँछ। भनेपछि हामीले त्यही यसलाई चाहिँ काटेर त्यही 120 भनेको त्यही 1.2 मिटरको हुँदाखेरि त्यसको सर्फेस एरिया कति छ भनेपछि त्यसैले गर्दाखेरि हाम्रो तलदेखि माथिसम्मको टोटल एरिया आउँछ भनेर लिएको है, ठिक छ। अब त्यसको लागि के चाहियो हामीलाई लेन्थ र हाइट चाहियो, ठिक छ। भनेपछि अब यसको लेन्थ भनेको त हेर त हाम्रो यो बिचको लेन्थ त होइन, हाम्रो त सर्फेसमा लाउने हो, त्यही भएर हाम्रो यो सर्फेसको चाहिँ लेन्थ चाहियो नि, ठिक छ। भनेपछि यो सर्फेसको लेन्थ भनेको कति हो भन्दाखेरि यति ट्रिगोनोमेट्रिक रिलेसनबाट निकाल्यो। या हाम्रो यो 60 डिग्री छ र यो इक्वल भएपछि यो हाम्रो इक्विल्याटर ट्रायंगल हुन्छ भनेपछि यो 1.2 मिटर भयो, यो पनि 1.2, यो पनि 1.2 मिटर हुन्छ है, ठिक छ। भनेपछि यो हाम्रो यो जुन इन्क्लाइन पोर्सन छ यो भनेको 1.2 मिटर आयो र इन्टु मैले हाइट गरेपछि के आयो, यो जुन सर्फेसको एरिया छ नि हो सर्फेसको एरिया आयो। ल मेरो पोइन्टिङ गर्ने या प्लास्टरिङ गर्ने भनेको के हो, यो सर्फेसको एरियामा हो नि त, ठिक छ। त्यही भएर यो सर्फेसको एरिया चाहिँ निकालेको है। र अब यो सर्फेस के छ ठ्याक्कै हाम्रो दुईतिर छ, त्यही भएर के गर्यो त्यो सर्फेसको एरियालाई मेरो इन्टु 2 गरेको है। भनेपछि त्यही हाम्रो त्यही दुईटा एरिया छ, त्यही भएर इन्टु 2 गर्यो, ठिक छ। हाम्रो लेन्थ 1.2 आयो, हाइट कति छ 3.6 भएपछि त्यताबाट चाहिँ टोटल मेरो बाहिरको त्यो पोइन्टिङ गर्ने सर्फेस एरिया चाहिँ त्यसरी निकालेको है, ठिक छ।
ठिक छ सर।
भनेपछि सेप्टिक ट्याङ्क र सोक पिटको चाहिँ एस्टिमेसन नजाउँ है।
Hello everyone, today we are going to do the estimation of the septic tank and the soak pit. Here is the section of the septic tank. and this is the top view of the septic tank. Similarly, this is the section of the soak pit, and this is the top view of the soak pit. The actual 3D view of the septic tank is this. So here is the section of the septic tank, and this is the 1:3:6 cement concrete, and here is the slope of 1:20. These are the brickworks in both sides, and this is the baffle wall, and this is the cover, that is the RCC roof slab, and this is the inlet pipe, and this is the outlet pipe. And here is the 3D view of the soak pit. You can see that this is the roof cover slab of the soak pit. This is the brickwork. The outermost part is the 15 centimeter coarse sand portion, and this inner portion is the 15 centimeter brick aggregate portion. So the section of the soak pit is this. Here we can see that this is the brick aggregate which is laid in this soak pit. This is the brickwork portion. The outermost portion is the 15 centimeter coarse sand, and this portion is the brick aggregate portion. Here. Now, our first step is to calculate the earthwork in excavation for the septic tank. That means we have to do the excavation of the septic tank from this portion up to this portion and up to the height of the ground level. That means we have to do the excavation of the length from this point up to this point. So we have to first calculate the length of this septic tank. Here we can clearly see that the inner dimension of this septic tank is 200 centimeter, and this small portion is 20 centimeter, and this portion is also 20 centimeter.
यो तिमीहरूको टप भ्यू भयो, यो चाहिँ हाम्रो क्रस सेक्सन भ्यू है। अब टप भ्यूबाट हाम्रो लेन्थ र विथ आउँछ, क्रस सेक्सनबाट हाइट आउँछ भनेर यसरी दुईटा फिगर यसरी गरेर देखाएको हो है।
And we have already given that this portion of the wall, that means from this wall up to this wall, is 40 centimeter, and this point up to this point we have 30 centimeter dimension. So now we have to calculate the small length, and this length is this wall 30 centimeter minus this wall 20 centimeter. So the small portion is 30 minus 20, that is 10 centimeter here. And similarly in this case also, this wall is 30 centimeter from this point up to this point, and this portion is 20. So this length is 10 centimeter. And similarly, now we have to find the length of this point to this point. So we have this total length 40 centimeter, and this wall is 30 centimeter. So this small portion is 40 minus 30 equals to 10 centimeter. So we have this wall also 10 centimeter, and this small portion is also 10 centimeter. So we get this total length 280 centimeter.
I had a little framework that I applied to the program research.
That means we get this 280 from this outer point to this point. So our length of excavation.
ठिक छ हेर त, यो ब्रिकवर्क भनेको यो माथिको ब्रिकवर्कको पोर्सन भयो, त्यसपछि अलिकति निस्केको पोर्सन भनेको यो ब्रिकवाला पोर्सन भयो, र यो तलको यो भनेको यो तलको पोर्सन चाहिँ यो देखेको है टप भ्यूमा। भनेपछि यहाँदेखि हाम्रो आउटर टु आउटर टोटल लेन्थ चाहिँ 280 त्यसरी निकालेको है।
Excavation is 280 centimeter, that is 2.8 meter. So we get the total length 2.8 meter. Now we have to find the breadth of the excavation. To find the width, we have to calculate the total length from this point up to this point. And we have already this inner dimension of this septic tank 90 centimeter from this point to this point. And this portion of this wall is 20 centimeter, and this is also 20 centimeter. We have the length of 30 centimeter from this point up to this point. That means this small portion is 30 centimeter minus 20 centimeter wall. That is, this small portion is 10 centimeter from this side and this side also. And similarly, we have this portion 40 centimeter, and this wall is 30 centimeter. So this small portion is 40 minus 30 equals to 10 from this side. And here also same process. That is, this wall is 40 and this wall is 30. So the small portion is 40 minus 30 equals to 10 centimeter. So the total width of this septic tank is 10 plus 10 plus 20 plus 90 plus 20 plus 10 plus 10, that is 170 centimeter. That is the width equals to 1.7 meter. So I can write the breadth equals to 90, that is 0.9 plus 2 into 0.2 meter wall plus 2 into 0.1 projection from both sides, and again 2 into 0.1 projection from both sides. So we get the width equals to 1.7, and now we have to calculate the height of excavation. We have to do the excavation from this point up to the ground level. The height of excavation is from this point.
अब हाम्रो यो सेप्टिक ट्याङ्क राख्ने भनेको पुरै अन्डरग्राउन्डै राख्ने हो भनेपछि हाम्रो ग्राउन्ड लेभल यहाँ छ भनेपछि यहाँ ग्राउन्ड लेभलदेखि तलसम्म मेरो के गर्नु पर्यो पुरै खाल्टो चाहिँ खन्नु पर्यो है
Point up to this point, and we have this small portion 20 centimeter, that is this portion is 20 centimeter height, this is also 20 centimeter, but we can clearly see that there is a slope of 1 in 20. That means we have this height 10 centimeter and the height is not constant all over this length. Height clearly see that is point.
यो मिड पोर्सनबाट किन गर्न खोजेको छ भन्दाखेरि किनकि हाम्रो यो जुन डाइमेन्सन दिएको छ नि यो 140 भनेर जुन दिएको छ यो भनेको यहाँदेखि मेरो यो बिचको पोर्सनसम्मको दिएको हो यो यहाँदेखि यहाँ साइडको पोर्सन हैन यहाँदेखि यहाँसम्म नि हैन यो बिचको पोर्सनसम्म दिएको छ त्यही भएर मेरो टोटल हाइट कति खन्नु पर्यो त्यो निकाल्दाखेरि यो 30 भयो यो 140 भयो बिचसम्मको भयो त्यही भएर यो बिचको डाइमेन्सन चाहियो अनि प्लस तलको डाइमेन्सन गर्नु पर्यो भनेर यो बिचबाट चाहिँ गरिरहेको है किनकि हाम्रो यो डाइमेन्सन नै बिचबाट दिइरहेको छ अब हाम्रो यहाँ साइडबाट टोटल यहाँसम्म 30 अनि यहाँसम्म मेरो 140 अनि यति त हाम्रो 20 छँदैछ ठीक छ मेरो यहाँसम्म दिएको भए त्यही अनुसारले यहाँ बाहिरको अनुसारले हिसाब गर्नु पर्थ्यो तर यो 140 चाहिँ मेरो यो बिचको यो जुन यो यहाँ त मेरो इन्क्लाइन पोर्सन छ नि त यो कङ्क्रिटिङ त यसरी स्लोप बनाएको छ हाम्रो यो सोलिड वेस्ट चाहिँ यतातिर सेटल होस् भनेर ठीक छ त्यही भएर यो स्लोप पोर्सनको बिचबाट चाहिँ हाम्रो यो डाइमेन्सन दिएको भएर यो बिचको चाहिँ डाइमेन्सन कति हुन्छ भनेर निकालेको है ठीक छ अब यो ट्रायंगलमा हेर्दाखेरि यता 0 मिटर भयो यता हाम्रो टोटल हाइट 10 मिटर छ भनेपछि ठ्याक्कै बिचमा कति हुन्छ मेरो 10 को आधी भनेको हाफ हुन्छ भनेपछि 5 सेन्टिमिटर हुन्छ है त्यही गर्न खोजेको हो यसमा चाहिँ
up to this point, and we have this small portion 20 centimeter, that is this portion is 20 centimeter height, this is also 20 centimeter, but we can clearly see that there is a slope of 1 in 20. That means we have this height 10 centimeter and the height is not constant all over this length, so we have to calculate the height at the midpoint. That means we have this inner to inner portion of this septic tank 200 centimeter from our top view, that is this inner to inner portion of the septic tank, that means from this point to this point is 200 centimeter. That means we have this portion 10 centimeter height and we are going to find the small height at the midpoint. That means this length is 200. At the length of 200 we have the height of 10 centimeter, and at the length of 100 centimeter, that is 200 by 2 at the midpoint. We are going to find this unknown value, and by solving this we get the value of x 5 centimeter. That means the small portion is 5 centimeter and we are going to find the height of excavation from this point up to this point, so we can easily write this height 20 centimeter plus this small portion 5 centimeter plus this portion 140 and plus this small portion is 30. So we get our height of excavation, that is 195 centimeter. That is our height equals to 1.95 meter. So I can write the height equals to 0.2 meter this portion of cement concrete plus slope of 5 centimeter, that is 0.05 plus this portion 140 plus 30, that is 1.4 plus 0.3 meter. So we get our total height of 1.95 and the total quantity we get is 9.28 and the unit is cubic meter. Now our next step is to calculate the earthwork in excavation for the soak pit. Now we are going to do the excavation of the soak pit, and here we can clearly see that we have to do the excavation in two parts. That means this upper portion and the lower portion.
अघि चाहिँ के थियो भन्दाखेरि हेर त हाम्रो सबसे लोएस्ट पोर्सनको के थियो विथ डाइमेन्सन सबसे बढी थियो त्यही भएर यसको लागि खन्नलाई नि के गर्नु पर्थ्यो माथिबाट सबै खन्नु पर्थ्यो त्यही भएर यो टोटल विथमा खन्यो ठीक छ अब यसमा चाहिँ के छ भन्दाखेरि हेर त हाम्रो सबसे तलको पोर्सनको के छ विथ त कम छ नि त त्यही भएर यो पोर्सनसम्म चाहिँ मेरो के भयो यो पुरै डाइमेन्सनको खन्नु पर्यो ठीक छ र अब त्यसपछिको तलको पोर्सन चाहिँ के भयो मेरो यति मात्रै खने पुग्छ यो साइडको खनिरहनु पर्दैन नि त त्यही भएर यसमा चाहिँ दुईटा पोर्सनमा छुटाइदिएको हो
portion because we are going to do excavation in the lower portion from this point to this point only, but at the upper portion, we have to do the excavation from this point to this point. That means we have different diameter for the excavation. First, let's do the soak pit of the upper portion. That means this portion. We have to do the excavation for the circular trench from this point, the ground level. We know the formula for the area of the circle, that is pi by 4 into d square, and we have to calculate the diameter from this outer to outer portion. So the total diameter of this outer to outer edge is 100 centimeter inner to inner portion plus 20 centimeter from both sides plus 15 centimeter on both sides, and this portion is also 15
हेलो मेरो आवाज आइरहेछ
आज सर आज
हेलो
आइरहेछ सर आइरहेछ
इयरफोनले काम गरेन कि ठ्याक्कै बत्ती गएछ डाटा लिएँ तर ठ्याक्कै फेरि ल्यापटपमा चार्ज सकिरहेछ
बत्ती आउला नि सर एकछिनमा
एकैछिन वेट गरौँ न त है
हुन्छ सर हुन्छ
छिटै आउँछ ल बत्ती आयो एकैछिन चार्ज जोडेर ल्यापटप खोलिहाल्छु मेरो आवाज आइरहेछ
आज सर आज
कन्टिन्यू गरौँ त्यही सोकपिटको चाहिँ हाम्रो एक्जाभेसनको लागि निकाल्न लागेको थियो यो सोकपिटको तल र माथि छुट्टा छुट्टै हुन्छ भन्ने कुरामा त बत्ती गएको थिएन नि है के त्यतिखेर बत्ती गइसकेको थियो हेलो
हजुर सर हजुर के भन्नुभयो सर
यो सोकपिटको यसरी यो तल पोर्सन र माथि पोर्सनमा चाहिँ तलमा चाहिँ यति मात्र एक्जाभेट गर्नुपर्छ माथि चाहिँ ठुलो विथको एक्जाभेट गर्नुपर्छ हाम्रो यो सेप्टिक ट्याङ्कमा चाहिँ तल सबसे धेरै विथको थियो त्यही भएर तलैदेखि माथिसम्म यति नै विथको एक्जाभेट गर्नुपर्छ भनेर त्यो कुरा भएको हो
भन्नुभयो थियो
यहाँसम्म भइसक्यो होइन ल ठिक छ
And the lower portion point circle that is 5/4 into d square and notion excavation. First, let's do the soak pit of the upper portion. That means this portion. We have to do the excavation for the circular trench from this point of the ground level. We know the formula for the area of the circle that is 5/4 into d square, and we have to calculate the diameter from this outer to outer portion. So the total diameter of this outer to outer edge is 100 centimeter, inner to inner portion plus 20 centimeter from
सर
both.
त्यो स्क्रिन कालो आएको हो कि के हो मेरोमा मात्र हो कि
स्क्रिन कालो आइरहेछ र
होइन आइरहेछ स्क्रिन सेयर भइरहेछ
तिम्रोमा के गएछ त अझै कालो नै आइरहेछ अब यसरी यो भिडियो उताबाट अनि यता प्ले गरेर रेकर्डिङ गर्दाखेरि त्यो अब नेट स्लो भएको ठाउँमा चाहिँ अलिकति ल्याग चाहिँ हुनसक्छ है कि अझै कालो आइरहेछ कि ठिक छ अहिले
आछैन सर कालो
मैं प्ले गरेँ है त
15 centimeter on both sides, and this portion is also 15 centimeter. That is, this is the 15 centimeter brick aggregate. So the total outer to outer dimension is 100 plus 2 into 20 plus 2 into 15 plus 2 into 15. So we get this outer to outer dimension 2 meter. So I can easily write area equals to pi by 4 into 2 square. And we have the number of soak pit 1, and we know that total volume equals to area into height. Here we can see that we have to do the excavation from this point up to the ground level, and we are going to do this as the lower portion. So in the upper portion we have the height of 250 plus 50, that is 300 meter height. So I can easily write the height equals to 2.5 plus 0.5, that is 3 meter, and by calculating this area into height we get our total quantity 9.42, and the unit is cubic meter. Now we are going to find the excavation in the lower portion. That means from this point to this point we have to calculate the total diameter. So our total diameter equals to 100 centimeter plus 20 centimeter wall from this side and 20 centimeter wall from this side. So we get the total diameter of 1.4 meter, and we have the height of the excavation of lower portion, that is 20 centimeter height. So I can write the numbers 1, and we have the area of the circle pi by 4 into d square, in which diameter equals to 1.4, and this height is 0.2. So height equals to 0.2, and we get the total quantity 0.3. Unit is cubic meter. Now we get the total 19 cubic meter. Now our next step is to
केही कन्फ्युजन छ यसमा
छैन सर
calculate this cement concrete of 1:3:6 ratio. That means here we can see from the section, that is, we are going to do this cement concrete in this dotted portion. That means we have this as the rectangular portion, and this portion is our sloping portion. That means we are going to put this cement concrete all over this septic tank, and in the inner side there is also a sloping portion. There also we put this cement concrete. So we are going to calculate this as floor and foundation. That means this lower portion, that is rectangular portion, and this sloping floor, that is this slope portion. So we have number 1, and the length is this outer to outer length. That means this point to this point we have length of 2.8 that we have already calculated. So length equals to 2.8, and we have already calculated the width. That means from this point up to this point, that is the outer to outer width. So we have already calculated this breadth, so I can easily write 1.7, and we have the height of 20 centimeter, that is 0.2 meter. So we get the total quantity 0.95 cubic meter. Now we are going to do this sloping floor, that is the triangular portion. So we have this total inner to inner length 200 centimeter. So if you find the area of this triangle, that means 1/2 into base into height and multiply by this width, that means this width, then we will get the total volume. So we can simply write 1/2, and base is our 200 centimeter. So I can write 1/2 into base into height, and here we have the base from this point to this point is 200 centimeter, that is this point, and we have the height of 10 centimeter. So I can write the area equals to 1/2 into base. That means this portion to this portion we have the dimension of 2 meter, and we have the height of the small portion, that is 0.1 meter, and we have to multiply this area by its width, and we have the width of this 90 centimeter, that is 0.9 meter. So into 0.9. Or we can also do another method for calculating cement concrete in the sloping floor. For this we have the number 1. We have to calculate this length into breadth of this portion. That means 200 into its width, that is 0.9, and we have to multiply by the height of this mid section. That means we have already calculated the small height at this middle point is 5 centimeter, that is 0.05. So I can write the length equals to 2.
यो भनेको चाहिँ अब खासै नजाइने कुरा हो, त्यही हाफ बेस इन्टु हाइट गरेको कन्सेप्ट नै त्यही त हो नि होइन। यता हाइट 0 हुन्छ, यता हाइट 10 हुन्छ, त्यही भएर हाफ भनेर पछि रेक्ट्याङ्गलको हाफ हुने भयो। ठिक छ, दुईटाको एभरेज भनेको हाफ भयो, अनि बेस इन्टु हाइट भनेको त्यही कन्सेप्ट नै हो है। त्यही भएर यो खासै
meter. So the width is 0.9 and the height of this slope portion at its midpoint is 5 centimeter, that is 0.05 meter. So we get the same, that is 0.09 cubic meter. So you can do by any method among these two. Total quantity is 1.04. Now our next step is to calculate this first class brickwork in the cement mortar for the septic tank. That means this brickwork portion. And here we can clearly see that we have the number of footing 2 in number. That is, this is the first footing and this is the second footing. So we are going to do this by long wall short wall method. When we see this portion, that is this 30 centimeter brickwork portion in the top view, then it will look like this. That means these all walls are of 30 centimeter and we are going to do by long wall short wall method. Here we can clearly see that we have the 2 number of long wall. That means these 2 portions are our long wall and these 2 portions are our short wall. Here also we have these 2 short wall. So we have this outer to outer length, that is 200 plus this wall 30 and this wall 30. So the total length is 260 centimeter, that is 2.6 meter. And so here we have the long walls 2 in number, so number equals to 2, and the length equals to this inner to inner portion 200 plus this wall is of 30 centimeter and this wall is of 30 centimeter. So I can easily write 2 plus 2 into 0.3 meter wall, that is 2.6 meter. So length is 2.6 and we have the width of the wall 0.3, that is these all portion are of 0.3 meter, that is 30 centimeter. And we have the height of the first class brickwork up to this portion, that is 60 centimeter. So the height is 0.6. So the total quantity is 0.94. Now we are moving to this second footing, that means these 2 portions of 20 centimeter width. So we have obviously number of long walls 2 in number. That means we have this second footing and we have this long wall 2 in number. That means this portion and this portion. And we have the length of this inner portion is 200 centimeter, that is 2 meter, and this wall of 20 and this wall is also of 20. That means the outer to outer length of this long wall is 240. So I can easily write the length equals to 2 meter wall plus 2 times of 0.2 meter width of the wall, that is 2.4 meter. So the length equals to 2.4 and we have this width of the wall 0.2 meter. That means this portion is 0.2. And now we have to calculate this height, that means from this point to this point. So we have already calculated this total height of this septic tank at this center is 195. That means you can see in the first step, that means height of excavation. To calculate this height, we have to subtract this 20 centimeter and this 60 centimeter. So 195 minus 20 centimeter minus 60 centimeter is 115, that is 1.15 meter. So we can easily write this second footing height equals to 1.15 meter. So we get the total height of 1.15 and the total quantity is 1.1 cubic meter.
ठिक छ। अब त्यही लङ वाल सर्ट वाल मेथडमा त लङ वालतिर आउटर टु आउटर डाइमेन्सन लिने हो, सर्ट वालतिर इनर टु इनर डाइमेन्सन लिने हो भनेर त्यही तरिकाले गरेको। यसमा नबुझिने त खासै केही छैन होला है। केही छ यसमा कन्फ्युजन?
छैन सर।
Now we are going to find this short wall. That means here we have already calculated this long wall from these 2 portions and now we can clearly see the short wall is this portion and this portion. So we have this length of the short wall is 90 centimeter, that is 0.9 meter. So we can write the number of the short wall 2 having the length of 0.9 and we have this width same, that is 0.3, and we have this height same, that is 0.6. And similarly we have this second footing also 2 in number and we have already considered these 2 as the long wall and the remaining is these 2 short wall, that means this portion and this portion. That means the length of this short wall is 90 centimeter. That means here also we have this point to this point 90 centimeter. So we can easily write the length equals to 0.9 and the width is same, that is 0.2 meter, and height is also same as the second footing, that is 1.15. And here we get the total quantity 0.32 and here we get the quantity 0.41. So while adding all these we get the total quantity 2.77. Now we are going to calculate this second class brickwork in the soak pit, and here we can clearly see that this portion is our dry brickwork and this portion is brickwork with 1:6 cement mortar. And one thing you have to remember is while calculating this brickwork, that means this is our hollow portion. So while calculating this hollow portion, we have to find the CSA, that is the perimeter into length. And
ल अब त्यही यो सोक पिटको कुरा भनेको त अब यहाँबाट त पानी त सोच्नु पर्यो नि त, ठिक छ। त्यही भएर यहाँ चाहिँ के हुन्छ भन्दा ब्रिकमा चाहिँ मोटर राखेको हुँदैन है, ब्रिकमा चाहिँ राखेको हुन्छ। अब यो त्यही सेन्टरमा त्यही कुरा। अब यो माथिको तल पोर्सनमा चाहिँ अनुसार चाहिँ हाम्रो यहाँ चाहिँ मोटर चाहिँ ब्रिक छ, यहाँ बिचमा चाहिँ हाम्रो ड्राई पोर्सन छ भनेर भनेको है। ठिक छ, ड्राई पोर्सन मतलब के हो, बिचमा मोटारहरू लगाएको छैन भनेर भनेको है, एउटा कुरा यो हो। र अब अर्को कुरा भनेको अब अहिलेसम्म हामीले त्यही रेक्ट्याङ्गुलर पोर्सनहरू गरिरहेको थियौँ, ठिक छ। अब यसमा त के छ, यसरी कर्भ सर्कुलर पोर्सन छ नि त, त्यही भएर यसको के गर्नुपर्छ भन्दाखेरि चाहिँ यसमा चाहिँ सेन्टर लाइन मेथडबाट चाहिँ गर्दाखेरि सजिलो हुन्छ है, ठिक छ। अब सेन्टर लाइन मेथडबाट गर्दाखेरि के गर्नु पर्यो, यसको सेन्टर टु सेन्टर यसको यो कर्भ डिस्टेन्स कति छ त्यो चाहिँ निकालेर अनि त्यसलाई यसको थिकनेस अनि इन्टु हाइट गरेपछि के आउँछ, मेरो टोटल ब्रिकवर्कको क्वान्टिटी आउनु भयो है।
while calculating the perimeter, we have to use the formula pi into d. Diameter is the center to center diameter. So firstly, we have to calculate this upper portion, that means these portions. And here we can clearly see that this is a circular portion and this is hollow inside. So upper portion number 1, and we have this wall 20 centimeter, this is 100 and this is 20. But while calculating this diameter to find the CSA, we have to find the center to center length. That means from this point up to this point. That is total diameter equals to 100 centimeter plus 20 by 2 from this side and 20 by 2 from this side. That means if you multiply this center line by its breadth, that is 20 centimeter, then we will get the total CSA of this circle. So I have to write the diameter equals to 120, and we have the perimeter of the circle pi into d, and pi d is our length, and if you multiply by this width, that is this width is 0.2 meter, that is this portion 20 centimeter, so width equals to 0.2, and we have to multiply by its height. And now we have to calculate this height of this upper portion. That means this is the brickwork in the upper portion, so the height is 50 centimeter, that is 0.5 meter. And we are also going to do this brickwork in this lower portion, and we have this diameter same, that is 100 plus 0.2 by 2, and here also 0.2 by 2, that is diameter equals to 1.2 meter, same, but height equals to 20 centimeter. So I can write the numbers equals to 1, perimeter is same, that is pi into 1.2, and the width is also same, that is this width is also 0.2, so width equals to 0.2, and the height is 0.2. And here the total quantity is 0.58. Now we have done this brickwork in this upper portion and this lower portion, and this middle portion is remaining, and we have this middle portion.
अब यही माथि हाम्रो ब्रिकवर्क भनेको मोटार सहित हो, तल पनि सेम त्यही 1:6 रेसियोकै मोटारको सहित हो, त्यही भएर दुईटालाई एउटै हेडिङमा निकाले, ठिक छ। र अब यो बिचको चाहिँ के हो, मेरो ड्राई ब्रिक हो, त्यही भएर यसलाई चाहिँ छुट्टै हेडिङमा गरेको हो है। यसलाई पनि यो ब्रिकवर्क भनेर यो ड्राई ब्रिकलाई पनि एउटैमा राख्न मिल्दैन है, किनकि अब यसको प्रोपोर्सन निकाल्दाखेरि अस्ति त जुन हामीले रेट एनालाइसिस निकाल्यो नि हो, रेट एनालाइसिस निकाल्दाखेरि के छ, पहिला क्वान्टिटी इस्टिमेट गर्दाखेरि के छ, सिमेन्ट स्यान्ड मोटार यो इँटाहरू कति हुन्छ सबै निकाल्छौँ नि त हो। अब त्यो गर्दाखेरि हेर त मैले यो भोल्युम यसलाई पनि यहाँ माथि नै मैले इन्क्लुड गरेर यो भोल्युम टोटल भोल्युम निकाल्यो भने चाहिँ के हुन्छ हेर त, यो त मेरो मोटार सहितको भोल्युम होइन नि त हो, त्यही भएर फरक गर्नुपर्ने हुन्छ है। प्लस यदि यसको सिमेन्टको रेसियो पनि फरक पऱ्यो भने के हुन्थ्यो, मेरो यहाँ तल चाहिँ 1:3 माथि चाहिँ 1:6 भए के हुन्थ्यो, त्यसको पनि छुट्टै गर्नु पर्थ्यो, किनकि त्यही रेट एनालाइसिस गर्दाखेरि जुन हामीले क्वान्टिटी निकाल्छौँ यो सिमेन्ट मोटारले चाहिँ फरक पर्ने हुन्छ है, यसको रेसियो प्रोपोर्सनले चाहिँ।
As this dry brickwork, so we are doing this in the separate topic. So we are going to do this middle portion, that means from this point up to this point, and we have the numbers 1. Our perimeter is same, that means pi into d is same as above. And we have this width 0.2 meter, same, that means this portion is also 0.2, and the height is 2.5 meter, that means this point to this point is 2.5 meter, so height equals to 2.5. Now we are going to do this RCC work for this soak pit and the septic tank, and we have this RCC work in this upper portion, that means this roof cover, that means this roof cover is our RCC portion. Here we can clearly see this is 7.5 centimeter RCC slab. Similarly, in this septic tank also there is the roof cover slab that is 7.5 centimeter RCC slab precast, and another RCC work is here, that is 4 centimeter RCC baffle. That means we have only 3 RCC work. So first let's do this roof cover slab of septic tank. So the number is 1. So this is the roof cover of the septic tank, and we have to find this total area of this septic tank, and we have to multiply by this height. We have the roof slab from this point up to this point. So the total length from this side up to this side is 200, that is inner dimension of the septic tank, plus 20 centimeter wall plus 20 centimeter wall, that is 240. So I can write the length equals to 2 meter inner dimension plus 2 times of 0.2 wall, that is 2.4. Roof cover is placed in this way. That means we have to find the width from this point up to this point, that is this length is 90 plus 20 plus 20, that is 1.3 meter. Here also we can visualize this is 1.3 meter. So width equals to 0.9 plus 2 into 0.2 meter wall, that is 1.3 meter, and the height of this RCC slab portion is 7.5 centimeter, that is 0.075. So the total quantity is 0.234. Now our next step is to calculate the roof cover slab of the soak pit. That means we have to place this cover in this whole circular portion. So we have to first find the area of the circle, that means pi d square by 4, and multiply by this height. So we have this RCC slab in this portion, that is from this point up to this point. So the total diameter equals to 100 plus 20 plus 20. And one thing you have to remember is while calculating the area, we have to find the total surface area. That means we don't need to find the diameter of center to center diameter. We can find the diameter from outer to outer point. Just remember that while calculating the perimeter, you have to find the diameter, which is the center to center diameter. And while calculating the area, that means while calculating pi d square by 4, you have to find the outer to outer dimension.
अब यसमा चाहिँ हामीले यो पुरै भित्रको सबै एरिया चाहिने हो, त्यही भएर पुरै बाहिरको डाइमेन्सन इन्टु पुराको बाहिरको डाइमेन्सन लिएर एरिया इन्टु हाइट गरेपछि आउँछ भनेर भन्न खोजेको हो। तर यो हाम्रो यो जुन भित्रको यो ब्रिक वर्क निकाल्दाखेरि चाहिँ के हुनुपर्छ, हाम्रो यो पुरै बाहिरको टोटल एरिया चाहिने हैन नि त। हामीलाई त यतिको हाम्रो यो के भन्नु होलो पार्टको जुन बिचको पार्ट छ, यो बिचको पार्टको हटाएर बाहिरको पार्टको मात्रै निकाल्नु पर्ने हो नि त एरिया। त्यही भएर यो बाहिरको पार्टमा चाहिँ त्यही लङ वाल सर्ट वाल र हाम्रो जुन सेन्टर लाइन मेथड छ यसरी कर्भ भएको भएर सेन्टर लाइन मेथडबाट गरेको। यो भनेको चाहिँ हाम्रो यो पुरै क्रस सेक्सन एरिया चाहिने हो, त्यही भएर बाहिरकै टोटल एरिया इन्टु हाइट गरेपछि आउँछ भनेर भन्न खोजेको मात्रै हो है। त्यस्तो अब नर्मल कुरै नै हो।
So the outer diameter equals to 140, that is 1.4 meter. So I can write the diameter as 1 plus 2 into 0.2 meter wall, that is 1.4. The height of this RCC slab is 7.5 centimeter. So I have to write 0.075 meter. So the height is 0.075 and we get the total quantity 0.115 cubic meter. Now our next step is to calculate the RCC work in this baffle wall. That means we have this baffle wall of 4 centimeter thickness, and while calculating this length, there is a bearing of 5 centimeter on this side and on this side. So the total length of this baffle wall is 90 centimeter. That means this portion plus 5 centimeter plus 5 centimeter, that is 100 centimeter. So the total length of this baffle wall is 0.9 meter plus bearing on both sides, that is plus 2 into 0.05. So the total length is 1 meter. So we have this number of this baffle wall 1 in number, and the length is also 1. So we have this width of this baffle wall 4 centimeter. That means this portion to this portion is 0.04 meter. So we can write the width equals to 0.04. The height of this baffle wall is from this point to this point, that is 30 centimeter plus 15 centimeter. That is this point to this point is 0.45 meter. Here also 45 centimeter. So we can write the height equals 0.45. So here we get the
अब यो बेरिङ चाहिँ अब तिमीलाई क्वेशनमा दियो भने ठिकै छ, दिएन भने चाहिँ त्यही 5 सेन्टिमिटर चाहिँ अब यो जुन हाम्रो यो जुन आरसीसी छ यो त यतिकै अड्केर त बस्दैन, अलिकति भित्र त गाडेर त सपोर्ट दिनु पर्यो नि, ठीक छ। हो त्यही सपोर्टको विथ भनेको मेरो बेरिङको विथ भनेर 5 सेन्टिमिटर भनेको है।
total quantity 0.367. Now our next step is to calculate this cement plaster in the septic tank. That means we are going to do the plaster in all these inner surface and this floor also. And for calculating this floor, we will calculate this in the separate topic, and here we are going to calculate only on this.
एउटा कुरा है, अब त्यही तिमीहरूलाई एक्जाममा त यो सबै इस्टिमेट गर भनेर भन्ने होइन, ठिक छ। तिमीहरूलाई एक्जाममा यो कुरा इस्टिमेट गर भनेर भन्छ। ल सपोज मेरो त्यही 1:6 मोटार ब्रिक वर्क गर भन्यो भने के गर्नु पर्यो? बताइ 1:6 सिमेन्ट मोटार इन सोकपिट भनेर भने त्यही ब्रिक वर्क इन 1:6 भन्यो भने यो मात्रै गर्ने है, यो फेरि ड्राई ब्रिकको गरिरहनु चाहिँ पर्दैन, ठिक छ। ए हाम्रो यो माथि हेडिङ जुन छ त्यो हेडिङको कुरा मात्रै सोध्ने हो। हाम्रो प्रिकास्ट आरसीसी वर्क कति छ त्यो निकाल भनेर एस्टिमेट गर भनेर सोध्ने हो एक्जाममा, ठिक छ। सेकेन्ड क्लास ब्रिक वर्क 1:6 मोटार सोकपिटमा कति छ भनेर सोध्ने हो, ठिक छ। सेकेन्ड क्लास ड्राई ब्रिकको एस्टिमेट गर भनेर सोध्ने हो। यसरी हाम्रो हेडिङ जुन छ यो हेडिङको चाहिँ योको चाहिँ निकाल भनेर सोध्ने हो नि त एक्जाममा। त्यही भएर यो नसोधेको कुरा सबै निकालिरहनु चाहिँ पर्दैन है, सोधेको कुरा मात्रै डाइमेन्सन हेरेर निकाल्ने हो।
Is 0.45 meter. So you calculate this cement plaster in the 367. Now our next step is to calculate this cement plaster in the septic tank. That means we are going to do the plaster in all these inner surface and this floor also. And for calculating this floor, we will calculate this in the separate topic, and here we are going to calculate only on this sides wall. So while doing this plaster, we have to find the length and multiply by its height. Then we will get this portion. Length multiply by its height, we will get this portion. So we have the total length of the septic tank 200 meter, and the height of this plastering is 140 plus 30, because this portion is already cement concrete. So we have to do the plastering from this point up to this point. So we have the long walls. That means these two portions are considered as the long wall. That means this point to this point, and here also this point to this point. That means two number of the long wall having the length of the 200. So the long wall is number 2, length equals to 2, and we don't consider the width, we have to consider the height. That is, the height equals to 140 plus 30. 1.4 plus 0.3. That is 1.7. And we get the total quantity 6.8. Similarly, while calculating this short wall, that means now we are going to do the plastering on these walls. So we have this total length 90 centimeter. So the length equals to 0.9, and we have two number of short walls, and we have the height of this point to this point, that is 1.7 meter, and we get the total quantity 3.06. Now we are going to do this cement plaster in this floor. That means we can simply multiply this 200 into 90. That means this floor portion. So the number equals to 1, and the length is 2, width is 0.9. So we don't consider its height, and the total quantity is 1.8 meters square. Now our next step is to calculate this 50 mm size brick aggregate in the soak pit. So we are going to do this portion as the outer side of the soak pit, and this portion as the bottom of the soak pit. So we have this outer portion of the soak pit 1 in number, and we have to find the CSA, that is pi into d into length. So first let's find the diameter of this portion. That is, inner portion is 100 centimeter, that is 1 meter, plus these two wall are of 0.2, so 2 into 0.2 plus. While calculating the center to center portion, we have to find 15. This is 15 centimeter, but we have to write 0.15 by 2. And again, here also this is 15 centimeter, and we need to calculate 0.15 by 2 to find the center to center diameter. So we get the total 1.55. So the length equals to pi d, that is pi into diameter is 1.55, and so the width is 0.15, that is this portion is 0.15. So the height is this point to this point, that is 2.5 meter. So the total quantity we obtain is 1.83, but here at the bottom we can clearly see that this is not the hollow portion. That means here we can see that this is a solid portion. So here is a solid portion all over this soak pit, So while calculating this solid area, we have the formula pi d square by 4. But these are the hollow portions, so we have used the formula perimeter into length. So we have the numbers 1 and we have the formula pi d square by 4 where diameter equals to outer length. That is, this brickwork portion is from this point to this point. That is, this inner portion is 100 centimeter. So the diameter equals to 100 centimeter. That is 1 meter. So we can write pi by 4 into 1 square, and we have this height of this brickwork that is 20 centimeters. So height equals to 0.2 and the total quantity is 0.16. And now we are going to find this coarse sand portion. That is, this is the coarse sand of 15 centimeters. So this is also the hollow portion. So we can write the numbers equals to 1. And firstly, we need to find the diameter. That is the center to center diameter. We have to find the diameter from this point up to this point. This is 15 by 2. This is 15 centimeter. This is 20 centimeter. This is 100 centimeter. This is 20 centimeter. This is also 15 centimeter, and this is 15 by 2. So we have to calculate the total diameter from this point to this point, and we obtain 185 from this point up to this point. So diameter equals to this inner portion is 1 meter plus 2 times into 0.2. That means these walls are of 20 centimeter. And this aggregate is also 15 centimeter, 2 into 0.15, and plus, while finding the center to center, we have to do 2 into 0.15 by 2. So we get diameter of 1.85. So this is also the hollow portion. So we have to write pi into d. So pi into 1.85, and the width is, this coarse sand is of 15 centimeter. So 0.15. 15 centimeter coarse sand, and it is up to the height of 250, that is 2.5. So the total quantity is 2.18 cubic meter. And lastly, we have to find the iron footsteps. 1, 2, 3, 4 iron steps. So simply we have 4 number. So we have 4 nodes, 4 number. In this way, we simply
यो आइरन फुट स्टेप भने चाहिँ त्यही अब यो सेफ्टी ट्याङ्कीमा गएपछि माथि निस्किनु पर्यो नि मान्छे हो, मान्छे निस्किनु लागि आइरनको यसो बनाएको हुन्छ है यो हिँड्ने टेक्ने बाटो चाहिँ।
we have 4 number. So we have 4 nodes, 4 number. In this way, we have completed the estimation of the septic tank and soak pit for 25 users. Estimation of the 1, 2, 3.
के कन्फ्युजन छ यसमा? हैन भने अब अर्को हेरौँ है त। अब त्यही तिमीहरूको अब क्वेसन हेर्दाखेरि त्यो 3D दिमागमा बसेन भने अलिकति गाह्रो हुनसक्छ, तर 3D इमेज मजाले दिमागमा बसेको छ भने त डाइमेन्सन हेरेर निकाल्यो, खासै त्यस्तो केही गाह्रो हुँदैन है। प्लस यसमा अब मजाले 3D फिगर बनाएर मजाले बुझाइदिएको छ, त्यही भएर धेरै सजिलो हुन्छ होला है।
Hello everyone. Today we will be talking about
तिमीहरूको कलभर्ट, यो चाहिँ स्ल्याब कलभर्टको गर्न खोजेको है। कलभर्ट भनेको त्यही अब हाम्रो यो ब्रिजहरू भनेको लामो लामो स्पान भएको भयो, कलभर्ट भनेको के भयो, सानो सानो छोटो छोटो स्पान भएको ब्रिज नै हो है।
Hello everyone. Today we are going to do the detailed estimation of the slab culvert.
तिमीहरूलाई फिगर चाहिँ अब यस्तो दिन्छ, यस्तो दिँदाखेरि यो के हो भनेर झन् अलग परेर देखिन्छ। जस्ट यसको 3D फिगर हेरेपछि क्लियर हुन्छ है।
Having the span of 1.5 meter and the roadway of 4 meter. In this question, we have this half sectional plan view. We have half sectional elevation on ABCD, and we also have this half longitudinal section on CBEF. Firstly, we have to understand what is the abutment and the wing walls. In this half sectional plan, we can clearly see that we have these 4 wing walls. That means this portion is our wing wall, this portion is also wing wall, this portion is also wing wall, and this portion is also wing wall. Whereas we have 2 abutments, that means this portion and this portion. So here is a 3D view of the slab culvert, and we can clearly see that these are the wing walls. This is also wing wall, and here are 2 wing walls. Similarly, there is the abutment portion here and here. We have this roadway of length 4 meter, that means from this portion up to this portion is 4 meter, and we have these parapet walls on both sides of this slab culvert, and this is the earth slope of 1:1, and we can clearly visualize these abutments from this bottom side. Now we can clearly visualize these abutments from this.
तिमीहरूको एक्जाममा दिने क्वेसन भनेको चाहिँ यसरी यो पोर्सन चाहिँ देखा हुन्छ, अब यो त्यो देखाउँदाखेरि यो 3D इमेज नभएको भए त के हो भनेर अलिक बुझ्न चाहिँ गाह्रो हुन्थ्यो है।
बटम साइड
हजुर
अबुटमेन्ट भनेको चाहिँ के हो र एकचोटि देखाउनु न।
यो जुन हाम्रो अब यो जुन यो ब्रिजको यो पिलर भन्ने टाइपको हुन्छ नि, ठिक छ। अब यो यसमा त्यो मेसनरीको छ, ठिक छ। यसैलाई नै अबुटमेन्ट भनेको। अब जेनरली चाहिँ हाम्रो लामो लामो ब्रिज छ भने चाहिँ जुन इन पोर्सनमा बिचमा चाहिँ पायरहरू हुन्छ, ठिक छ। अनि लास्टको जुन इन पोर्सनमा राखिन्छ नि, इन पोर्सनमा चाहिँ अलिक ठुलो राखिन्छ, ठिक छ। अलिक ठुलो, त्यसले गर्दा साइडबाट मेरो साइड यो माटोहरूबाट आउने त्यो जुन अर्थ प्रेसर हुन्छ त्यो पनि धानोस् र यसको माथिको भर्टिकल प्रेसर पनि धानोस् भनेर राख्ने पोर्सनलाई चाहिँ अबुटमेन्ट भन्छ है। अब नर्मली बुझ्दाखेरि चाहिँ त्यही अलिक ठुलो पिलर भनेर बुझ्दाखेरि हुन्छ है अबुटमेन्ट भनेको चाहिँ। यसमा यो जुन छ नि यो ठ्याक्कै
बटमको चाहिँ
हजुर
विङ वाल हो त, बटमको कङ्क्रिट चाहिँ विङ वाल हो त बटमको।
ल पक्कै त। अब यो खासमा यो पुरै यो सबैको काम के हो भन्दाखेरि त्यही भर्टिकल लोड धानिदिने काम हो। यो पुरै अबुटमेन्टमै भनेर बुझ्दा हुन्छ। तर अब यो चाहिँ यसको स्टेबिलिटीको लागि चाहिँ यता अलिकति एक्सटेन्ड गरेर यसरी राखेको हुन्छ कि, ठिक छ। हो एक्सटेन्ड गरेर राखेको हुन्छ। यो एक्सटेन्ड गरेको अबुटमेन्टको पार्टलाई चाहिँ विङ वाल भन्ने टाइपको भनेको हो कि।
अनि त्योभन्दा माथिको चाहिँ त्यो मेसनरी स्ट्रक्चर चाहिँ एबटमेन्ट हो।
यो होइन, यो मेसनरी स्ट्रक्चरको पनि यो जति निस्केको पोर्सन छ नि, यो बिचकोबाट यो निस्केको पोर्सन जुन छ नि, हो यसलाई चाहिँ विङ पोर्सन भनेर भनेको हो, ठिक छ। एक्स्ट्रा यो जुन यो बिचको मेन पोर्सनबाट जुन निस्केको छ नि, हो निस्केको पोर्सनलाई चाहिँ विङ भनेर भनेको हो।
सो त्यो अबुटमेन्ट भनेको चाहिँ त्यो इन्क्लाइन त्यो पोर्सन जस्तै हो कि कुन चाहिँ हो?
कुन यो?
हजुर
त्यो त स्ल्याब हो कि।
इन्क्लाइन पोर्सन भनेको यो खासमा यो यतापट्टि नै हाम्रो के हुन्छ, माटो हुन्छ, उतापट्टि नि माटो हुन्छ। यो बिचमा खोला बगिरहेको हुन्छ नि त। खोला बगेको ठाउँमा यो माथि एउटा रोडवे बनाउनु पर्यो नि त हामीलाई, ठिक छ। हो भनेपछि अब यो यतापट्टिको चाहिँ हाम्रो यो यतापट्टिको माटो पनि एउटा सर्टेन इन्क्लाइनमा त हाम्रो स्टेबल भएर बसिरहेको हुन्छ नि। हो त्यो स्टेबल भएको पोर्सन पछि बल्ल हाम्रो के छ, स्ल्याब बनाउनु पर्यो भनेर यो यसरी इन्क्लाइन बनाइदिएको स्ल्याब हो है। यो भनेको एब्रुटमेन्ट होइन। यो जुन यो मेसनरीकै पोर्सन छ नि, यो जुन मेरो भर्टिकल लोड धान्नलाई माथिबाट जुन लोड आउँछ, यो त यसले यो मेसनरी थ्रुबाट मेरो ट्रान्समिट भएर तल फाउन्डेसनमा जाने हो नि। हो यो मेरो ब्रिकवर्कको भर्टिकल पोर्सन भनेकै मेरो एब्रुटमेन्ट हो है।
Clearly visualize these abutments from this.
यो पोर्सन भनेकै एब्रुटमेन्ट हो मेरो, यो भर्टिकल पोर्सन भनेकै
bottom side. Now let's visualize this half sectional elevation on ABCD.
अब यो तिमीहरूको यो फिगर हेऱ्यो भने त केही पनि बुझिन्न है। अब तिमीहरूलाई त एक्जाम आउने फिगर पनि यही नै फिगर आउने हो है। त्यही भएर अब यो झन् यो फिजिकल्ली बरु पढाउँदाखेरि यो बुझ्न अलिक गाह्रो हुन्थ्यो। अब यसरी 3D इमेज भएपछि अलिक सजिलो हुन्छ कि। अब तिमीहरूलाई क्लासमा पढाउने भए पनि मैले यही युट्युबको चाहिँ मैले यसरी प्रेजेन्टेसन गरेर देखाउँथेँ कि, त्यसले गर्दाखेरि माइन्डमा चाहिँ क्लियर इमेज बस्थ्यो है।
When we cut this half sectional plan, half is this abut. This is the earth slope. Is this wall and
यो फिगर दिएको छ, यो फिगरको चाहिँ कताबाट आयो
meter. That means from this portion up to this portion is 4 meter, and we have these.
र अब त्यसपछि तिमीलाई अर्को फिगर देखाउँछु। यो अर्को फिगर देखाउँछ। अब यो अर्को फिगर चाहिँ कसरी बनाएको भनेर
sectional elevation on ABCD. When we cut this, visualize this half sectional elevation on ABCD. When we cut this half sectional plan from this portion, that is ABCD portion, then it will look like this. So when we see
यो फिगर यसरी जुन त्यो एबीसीडी पोर्सनबाट काटेको छ नि, हो काट्दाखेरि चाहिँ यसरी देखिन्छ है। अब यही फिगरलाई चाहिँ यसरी देखाइदिएको हो है। अब यसमा 3D भ्यूमा मजाले बुझिन्छ। अब यसमा चाहिँ के गरे जस्तो हुन्छ है।
this object from this front view, it will exactly look like this. That means this portion, that is this 1.2 meter portion is this portion, this 70 centimeter portion is this portion, and we have this brickwork in this portion, and we have this RCC slab portion. Here we have this RCC slab portion here, and these are this parapet wall, that means these parapet wall portions. And we have this earth slope of 1:1, that means here also 1:1, and here is the hidden line. And we have this ground level, that means this is our ground level. In our question, we also have this half longitudinal section on CBEF. It means that when we cut this plan from this CBEF portion, it will look like this. Here is the CB section and here is the EF section, that means our CBEF section. And when we view this object from this front view, it will look exactly like this. Here we have this coping in this part, and this is our 30 centimeter width parapet, and this is our 40 centimeter width parapet, and this small portion is our 10 centimeter wearing coat, that means this portion. And these are the brickworks, and these are the lime concrete portion. This is also the lime concrete portion, and this is our bed level. And when we view this object from the front view, this portion will appear rectangle. So it look like rectangle here. Now our first step is to calculate the earthwork in the excavation, in the abutment as well as the wing walls. So we can see that we have to calculate the excavation of this portion, that means 70 centimeter width up to the ground level. That means up to the height of 30 plus 30, that is 60 centimeter height. So for this excavation work, we need to calculate the length of this abutment from this point up to this point. That is, we will get this length from this point up to this point.
अब त्यो एक्जाभेसन गर्ने भनेको यो हाम्रो ग्राउन्ड लेभलदेखि मुनि यो हाम्रो जुन यसको एबिटमेन्टको फुटिङहरू छ यो फुटिङ राख्न लागिलाई हामीले एक्जाभेसन गर्नु पर्यो है, त्यही भएर त्यसको एरिया चाहिँ निकाल्न खोजेको.
And we have to do the excavation up to the ground level. So our total length is 4.8 plus 15 centimeter plus 15 centimeter. So our length is 4.8 meter plus 2 times of 0.15. So we get our total length 5.1 meter. We have two number of abutment walls, that means from this portion and this portion. So number equals to 2, length equals to 5.1. The width is 70 centimeter, that is we have to do the excavation of 70 centimeter width. So width equals to 0.7 meter, and the height is up to the ground level. That means 30 plus this portion is also 30, that is 60 centimeter, that is 0.6, and we get our quantity 4.28, and the unit is cubic meter. Here we have already done the excavation of this abutment portion from these two abutments. Now we have to do the excavation in this wing walls portion, that means these 4 portions here and here. So we need the length of this portion to this portion, and we have already this length 1.2 meter, and here also the
There are a number of threats facing our planet.
How can we make energy locally?
What is conservation action?
the length is 1.2 meter, and we have this width of this excavation 0.7 meter, and the height of excavation is 60 centimeter, that is 30 plus 30 equals to 60 centimeter. So we can easily write the numbers equals to 4 and the length equals to 1.2 meter, which is already given. So length equals to 1.2 and the width is 0.7 and the height is 0.6 meter, and we get the total quantity 2.02 and the unit is cubic meter. Now our next step is to calculate the cement concrete in foundation. Here we can clearly see that the cement concrete in foundation is this portion, and these portions, and it is up to the height of 30 centimeter, that is this is of 30 centimeter height, and we will get the same length but only the height will be different. That is, we have the height of 0.3 meter, and we have two numbers of this abutments having the length of 5.1 meter, that is same as this method, and the width is also same, and the height is 0.3 meter, that is this portion. And our total quantity is 2.14. The unit is cubic meter. And here in this wing wall also we have numbers for the length is same, that is 1.2, breadth is 0.7 meter, and the height is 0.3 meter. So the total quantity is 1.01 cubic meter. Now our next step is to calculate this first class brickwork in 1:4 cement mortar. That means these brickwork portions, this also and this also. Here we can see that we have this brickwork in this portion, but we don't have this brickwork in this RCC slab, so we have to reduce this RCC slab later. Here we have to do this brickwork in this hatch portion. That means this 40 centimeter width and the length is 4.8 meter. That is from this point up to this point. So we can write the length equals to 4.8 meter and width equals to 40 centimeter. So the number of abutments 2, length equals to 4.8 meter, width is 0.4, and the height is, we have to see from this half sectional elevation, that is our total height of this brickwork is from this point up to this point. That is, we have this length 30 and this length is 1 meter and this length is 20 centimeter. This 20 centimeter can be easily seen from this half longitudinal section on CBEF. So this slab portion is 20 centimeter. This portion is 20 centimeter. So the total height of the brickwork is 1 meter plus 30 centimeter plus 20 centimeter. That is 1.5 meter. So I can write the height as 1.5 meter and our total quantity is 5.76 cubic meter. Now we have 4 number of these wing walls and we have to find the length. So for this we need to calculate the length from this point up to this point, and we have this length 1.2 meter and the small length is equals to 0.7 minus 0.4 by 2, that is 0.15 from this side and 0.15 from this side. And here also we have this 70 centimeter wall and there is 40 centimeter wall, so this portion is 0.70 minus 0.40 by 2, that is 0.15 on this side and this side. So we have all these small lengths 0.15 on all these sides. So the length of this portion is 1.2 plus 0.15 minus 0.15. So we get the length 1.2 meter here also. And our width is 40 centimeter, that is 0.4 meter width. So I can write the length 1.2 meter and width is 0.4 meter and the height is same as before, that is 0.3 plus this length is 1.3 and this slab portion is 0.2. Height is 1.5 meter and we get the total quantity 2.88 and the unit is cubic meter. Now we can see here that we have these parapet portions and these are also considered as the brickworks. Here also we have this brickwork portions. So we have to find the length of this brickworks. Here we have this length 4.9 meter from our half sectional elevation on ABCD, and this is our 10 centimeter coping from this side and here also 10 centimeter coping, but the actual length that we require is from this side up to this side because here is our parapet portion. So this length is 4.9 minus 0.1 from this side and 0.1 from this side. So our length equals to 4.7 meter. And in 3D, this length is from this side up to this side. And the width is 40 centimeter. So we have parapet up to the curve 2 in number. That means this portion and this portion, 2 parapets on both sides. And we have this length L equals to 4.9 meter minus 2 times of 0.1. That is 4.7 meter. And we have this width 40 centimeter parapet, so width equals to 0.4. And to calculate the height, we have this 40 centimeter width from this level up to this level. That means this height is 20 centimeter and this small portion is 10 centimeter wearing coat. So the total height of 40 centimeter parapet is 30 centimeter. That is, this portion is 30 centimeter. So we can write the height equals to 30 centimeter. So we get the total quantity 1.13 cubic meter. Now we have to do this parapet above the curve. We consider this portion as the parapet above the curve because we have here curved portion and we have to calculate this length from this portion up to this portion. So we have 2 number of this parapet from this side and from this side. So number equals to 2. We have the same length from this parapet as well as from this parapet. So length is 4.7. But we have the width of 30 centimeter. For the height, we have this 30 centimeter parapet from this portion up to this portion only. But we have the height of 60 centimeter from this height up to this height. That means we have to reduce this 10 centimeter coping. So our total height is 60 centimeter minus 10 centimeter. That is 50 centimeter. So we have this height of 0.5 meter and the total quantity is 1.41 cubic meter. Now we have to do this parapet coping. That means from this portion up to this portion. So here we have this total length of 4.9 meter, and the width of this coping is 0.4 meter, and height is 10 centimeter, that is 0.1 meter. So we have two number of parapet coping, that means from this side, and the length equals to 4.9, width is 0.4, and the height is 0.1. So our total quantity is 0.39 cubic meter. Now we have to deduct this small portion RCC slab on this side and on this side, because we don't do brickwork in this portion. That means we have to reduce this small portion from our brickwork. That means we have this portion, that is the width of this bearing, that is 0.3 meter from both sides, up to the height of 20 centimeter, that is 0.2 meter. And for the length, we have to calculate the total length from this side up to this side. That means the total length from this side to this side. So we have this total outer to outer length 4.8 meter. That means this portion to this portion is 4.8 meter. So we have to write the length equals to 4.8 meter. That means from this side to this side we have RCC slab. So we have two number of this RCC slab, that means from this side and from this side, having the length of 4.8 meter. So length equals to 4.8, and the width is 0.3 meter, that means this portion, and the height is 0.2 meter, that means this 20 centimeter. So we get the total quantity 0.58 cubic meter. Now our next step is to calculate this RCC work excluding steel and bending, but including centering and soldering. That means now we have to consider this RCC slab, and we have already calculated the length, that is 4.8 meter from this side up to this side. 4.8 meter, so length equals to 4.8 meter, and we have to calculate its width. Here we can clearly see that we have this RCC slab from this portion up to this portion. That means we have this total length 1.5 meter plus 0.3 plus 0.3, that is 1.5 plus 0.3 times of 2. So we get our total width 2.1 meter. B equals to 1.5 plus 2 times of bearing of 0.3, that is 2.1 meter, and we have this RCC slab of 20 centimeter. This portion is of 20 centimeter, so height equals to 0.2, and we get our quantity 2.016 cubic meter. Now we are doing this steel bar including this bending in this RCC work. It means that in this RCC slab we have to insert the steel bars of 3 types. That means of main bar and main bent up bar and distribution bars. So firstly we are going to calculate this main bar of 20 mm diameter. That means we have this 20 mm diameter main bars at the spacing of 15 centimeters center to center. So it means that we are going to put this main bar in whole of this RCC slab having the center spacing of 15 centimeter. And to calculate this number of how many bars that we have to put in this RCC work having the diameter of 20 mm, we have the formula, and that is number equals to length divided by center to center spacing plus 1 in the main bar. That means we have to put this steel bar from this portion up to this portion, and we have calculated this outer to outer length, that is 4.8 meter. That means this portion is 4.8 meter, and we have this center to center spacing 15 centimeter. So number equals to 4.8 divided by 15 centimeter, that is 0.15, and we have to add 1 for the main bars, so plus 1, and we get the total number 33. Now we are going to do this 20 mm diameter main bar of 15 centimeter center to center. There is a steel bar here, and this portion are called the hooks, and we assume this small hook is of 9 times of the diameter. Firstly we need to calculate this outer to outer distance. That means 1.5 plus 2 times of 0.3 meter, that is 2.1 meter from this side to this side, and we have to assume that these hooks are of 9 times diameter on both sides. So the total length equals to outer length 2.1 minus this cover of 4 cm from both sides, and again add this hooks of 9 times diameter from both sides. So I can easily write the length as 2.1 minus 2 times of 0.04 plus 2 times of 9 times of diameter, and we have the diameter of 20 mm, that is 0.02 meter. So the total length is 2.38, and we get the total quantity 78.54 meter. And our next step is to calculate this main bent up bar, and we calculate this number same process, but we don't need to add +1. That means our number equals to length divided by center to center spacing, and +1 is not needed. And we have this bent up bar of 30 cm center to center spacing. We provide bent up bar in this whole RCC slab, so length equals to 4.8 meter divided by center to center spacing is 30 cm, that is 0.3. That is number equals to 16. And here we provide these bent up bars at the top. That means we can clearly see that the length of this bent up bar is more than the length of this straight bars, and we assume this small bent up portion 16 cm. So in this straight main bar we have to add 16 cm to get this bent up bar portion length. The length equals to 2.38, that means the length of the straight bar plus 16 cm, that is 0.16, and the total length is 2.54. So length equals to 2.54, and our total quantity is 40.64 meter. And we assume that the weight of these steel bars of main bar is 2.47 kg per meter. So our total weight of the steel is 19.18 into 2.47. So we get the total weight 294.375 kg. Now we have to calculate this distribution bar of 10 mm. That means here we can see that there are the distribution bars of 10 mm diameter and 25 cm center to center spacing. That means these distribution bars are laid in this RCC slab. So we have to calculate this length. That means this portion is 2.1 meter, and we have this spacing of 25 centimeters center to center. So the total number of this is, we have the length 2.1 divided by center to center spacing, that is 0.25, and we don't need to add +1. So we get the total number 8.4, which is nearly equals to 9. So we can write this number 9. That means this distribution bars are kept all over this RCC portion like this. So we have to calculate this length of this steel bars, and the length is, this portion is 4.8 meter, and we have to reduce these two cover from both sides, and we have to add this 9 times of diameter, that is the hook portion from both sides. So length equals to 4.8 minus cover of 4 centimeter, that is 2 into 0.04, and plus 2 times of 9D. And the diameter of this distribution bar is 10 mm. So into 0.01, that is 10 mm. So the total length is 4.9 meter, and we get the total quantity 44.1 meter. And we have these 4 number of this top distribution bar. So the top distribution bar number is 4, and the length is same, that is 4.9 meter as above, and we get our total quantity 19.6 meter. Now we have to calculate the weight of the steel, and we have to calculate the weight of the steel at the rate of 0.62 kg per meter. So we get the total weight 39.49 kg. Now our next step is to calculate this cement concrete of 1:2:4 wearing coat. Here we have this wearing coat in this layer. That means here we can see that there is a 10 centimeter wearing coat from this portion up to this portion, that there now.
एउटा कुरा चाहिँ सुन है, यो जुन केजी पर मिटरमा निकालिरहेको छ नि हो, यसमा चाहिँ के गरेको भन्दाखेरि हाम्रो जुन स्टिलको हाम्रो डेन्सिटी त कति हो 7850 केजी पर मिटर क्युब छ नि हो, त्यसमा इन्टु यो स्टिलको क्रस सेक्सनल एरियाले मल्टिप्लाई गरेपछि यति पोर्सन आएको हो है। ठिक छ, केजी पर मिटरमा चाहिँ अब डेन्सिटी भनेको केजी पर मिटर क्युब हो, त्यसलाई एरियाले मल्टिप्लाई गरेर चाहिँ यति निकालेको है। यसमा पनि सेम केस हो है, यो कसरी आयो भनेर नचुक्किनु।
Our next step is to calculate this cement concrete of 1:2:4 wearing coat. Here we have this wearing coat in this layer. That means here we can see that there is a 10 centimeter wearing coat from this portion up to this portion. That means the total length of this wearing coat is 1.5 plus 0.4 meter, width of this wall and plus 0.4 meter width of this wall. That is 1.5 plus 2 into 0.4. That is the width is 2.3 meter. That means this portion is the width of the wearing coat, but we have this wearing coat all over this roadway width. That means we have the roadway width of 4 meter. That means here is the roadway of 4 meter. So the length of this wearing coat is 4 meter and the width is 2.3 meter, and we have the height of the wearing coat 10 centimeter, that is 0.1. So the total quantity is 0.92 and the unit is cubic meter. Now we have to calculate this cement pointing of 1:2. Firstly, we have to understand where is this cement pointing applied. So this cement pointing is applied over this exposed area. That means all these exposed portion. So firstly, we need to calculate the cement pointing from the face wall from ground level up to the bottom of the coping. That means we are going to do this pointing in this surface and we are going to consider this full rectangle, and later we will reduce this rectangular portion. And while doing this pointing, we have to assume that below the ground level we have to do the pointing up to the height of 0.1 meter. That means we have this portion as ground level, and below the ground level, that means this portion is 0.1 meter, and we have to do pointing up to 0.1 meter below the ground level. That means we are going to do this pointing from this portion up to 0.1 meter below the ground level. That means this portion up to this portion. So we have this length 0.1 meter and this height is 1.5 meter and this portion is 0.6 meter. But we do not do pointing in this coping, so we have to reduce this 0.1 meter height. That means this portion is 0.6 minus 0.1, that is 0.5 meter, and we will get this total length 2.1 meter. And you can visualize this figure here. That means this portion is 0.1, this height is 1.5 meter, and this portion is 0.5. So we are going to do pointing up to this height, that is 2.1 meter height. And we have this full length from this portion to this portion is 4.7 meter. That is 4.9 minus 0.1 and minus 0.1, that is 4.7 meter. And we are going to do this same pointing on another side. So we have numbers 2 having the length of 4.7 meter, and it doesn't consist of the width, so the height equals to 2.1 meter. That is h equals to 0.1, that is below ground level, plus 1.5 meter plus 0.5 meter. That can be clearly seen from this figure. So height equals to 2.1 meter, and we get our total quantity 19.74, and the unit is meter square. Now here we have already done this pointing on this surface and this surface. Now we are going to do this pointing in these inner sides of this parapet, excluding this coping. That means this side and this side. That means we have to see the height of this portion and the length from this point to this point, and we have to consider this 10 centimeter projection from the top side. We have already the height of 80 centimeter from this point to this point. That means this total height is 10 centimeter. That is the top projection plus 80 centimeter, and we have to reduce this coping of 10 centimeter height. That is the total is 80 centimeter height. And we have this length from this side to this side is 4.7 meter, that we have already calculated by 4.9 minus 2 times of coping of 0.1 is 4.7. So we can easily write that length is 4.7 and height is 80 centimeter. So we get the total quantity 7.52 meters square. That means we have done this cement pointing on this side, these two inner side, but we have not considered this coping. So now we have to do this coping from this top side and this inner portion. So we have the number of coping 2 in number, and the total length is 4.9 meter. That means this length is 4.9 meter from this side up to this side. So I can write the length equals to 4.9 meter. Now we are going to do pointing on all these top sides, these edges, and also this projection. So we have this total length 4.9 meter, and we have this length of this coping from the top 0.4 meter. That means this portion is 0.4 and this side portion is 0.1 meter, and here also 0.1 meter, and this small projection is 40 centimeter. Wall minus 30 centimeter, wall equals to 10 centimeter. So we get the total length of this coping 10, that is 0.1 meter plus 0.4 meter plus 0.1 meter plus 0.1 meter. That means this portion is 0.1, this 0.4 is this top portion, this 0.1 is this side portion, and this 0.1 is this projection. So we get our total width 0.7 meter, and we have this coping on both sides. That means here also we have this same length, so we have to consider two numbers of this coping, and we get our total quantity 6.86 meter square. Now the only part we have left is this side portion, this side portion, and this side portion, and this side portion. Now we are going to do this cement pointing on these ends of the parapet, that means this portion. So we are going to do this ends of the parapet, that means these two portions from one side and another two portion from the back side. So we have this total number 4, that means these two and the back side 2, so number equals to 4, and we have this width, that is 40 centimeter width of this parapet and up to the height of 20 centimeter, that means this portion. So we have the number 4 and we have the width of 0.4 and we have the height of 0.2 meter, that means this small portion. So we get the total quantity 0.32 and the unit is meter square. Now we are going to do this ends of parapets of 30 centimeter, that means this portion, and the back side 2 portions. So we have the numbers 4 and we have the width of 30 centimeter up to the height of 50 centimeter, that is this coping is not needed. So 60 centimeter minus 10 centimeter coping, so that is height is 50 centimeter, width is 0.3 and height is 0.5. So our total quantity is 0.6, unit is meter square. Now we are going to do this ends of the coping, that means we have 4 number of ends of this coping, that is this portion, and these 2 small portions here and here. So we have ends of coping 4 in number, having the width of 0.4 and the height of 0.1. And while calculating the height, we also need to calculate the small portion projection, that means this 0.1 meter projection. So we have to write the height equals to 10 centimeter coping plus this portion, that is under the side. So our total height is 0.2 meter. Here we have the width of the coping 0.4 and we have to write the height as 0.2 meter, considering this is an underside portion also. So the total quantity is 0.32. Now while doing this, we have not considered this small rectangular portion, so we have to deduct these portions, because while calculating this portion we have calculated all these portions like this, but we have to reduce this small portion from one side and another rectangular portion from another side. So we have 2 numbers of this rectangle and the length is, this portion is 1.5 meter, that is this small portion is 1.5 meter, so length equals to 1.5, and we have to reduce this height, that means the height is 0.1 meter from the ground level plus 1 meter and plus 0.2 meter, that is 1.3 meter. So height equals to 0.1 meter from the ground level plus this portion 1 meter plus 20 centimeter RCC slab, that is 1.3 meter. And we get our total quantity 3.9 and the unit is meter square. In this way, we have calculated all the detailed estimate of this slab culvert. If you like the video, please like, share and subscribe.
केही छ यसमा? हेलो, सबैजना निदाए कि हो? हेलो, मेरो आवाज आएको छैन?
आइरहेको सर
आइरहेको छ सर।
अब यो स्ल्याब कलबर्ट अलि कम्प्लिकेटेड चाहिँ छ। एकचोटि आफूले गरेपछि अनि यहाँ कहाँ के अड्क्यो त्यो कन्फ्युजन चाहिँ भाग्ला है। ठिक छ, अब त्यो आफूले गर्दाखेरि पनि अनि त्यसपछि केही कन्फ्युजन भयो भने सोध है। अहिले केही सोध्नु छ? छैन भने अब अर्को भनेको तिमीहरूको यो
यति गरौँ सर आज हुँदैन र?
यो चाहिँ खासमा तिमीहरूले आफै हेर भन्नलाई हो कि
होइन सर, अब हेर्नु नै गाह्रो होला जस्तो भयो। अब अर्को क्लासमा गरौँ कि?
ल ठिकै छ त्यसै। तर अब तिमीहरूको बाँकी भनेको यो अन्डरग्राउन्ड आरसिसी ट्याङ्क र वेल फाउन्डेसन भयो। अब तिमीहरूको यो सिलेबसमा चाहिँ यो एक्विडक्टको चाहिँ छैन है, तर एकचोटि चाहिँ सोधेको छ। यो जुन हाम्रो तिमीहरूले इरिगेसनमा जुन पढ्यो नि हाम्रो एक्विडक्ट भनेर, ठिक छ। अब यो एकचोटि चाहिँ सोधेको छ तर सिलेबसमा चाहिँ छैन। सिलेबसमा तिमीहरूको अब सिलेबस वाइज बाँकी भनेको चाहिँ त्यही यो अन्डरग्राउन्ड आरसिसी ट्याङ्क र वेल फाउन्डेसन हो। ठिक छ। अब यो आरसिसी ट्याङ्कमा म के छ भन्दाखेरि त्यही यो कङ्क्रिटिङको यति कङ्क्रिटिङहरूको निकाल्नुपर्ने हुन्छ, यो ग्राउन्ड यति एक्जार्भेसन गर्नुपर्यो भने निकाल्नुपर्ने हुन्छ, प्लस यति सिमेन्ट प्लास्टरिङ गर्नु पर्यो भनेर निकाल्नुपर्ने हुन्छ। ठिक छ, त्यही भएर त्यस्तो कम्प्लिकेटेड केही छैन। अब जस्ट यो भनेको चाहिँ इन्क्लाइन पोर्सन छ, त्यही भएर यो मिड पोर्सनलाई लिएर चाहिँ क्यालकुलेसन गर्नुपर्ने हुन्छ। अरू भनेको त्यस्तो कम्प्लिकेटेड केही पनि छैन यो ठिक छ। र त्यही अनुसारले हाम्रो यो वेल फाउन्डेसनमा के हुन्छ भन्दाखेरि भर्खर हामीले जुन हजुर
सर के अरे यो सिलेबसमा चाहिँ कन्स्ट्रक्सन अफ हाइवे फर 1 किलोमिटर लेन्थ पनि रहेछ, अनि अर्थवर्क इन क्यानल्स।
अर्थवर्क इन क्यानल्स त हामीले त्यही अस्ति एस्टिमेसन गरेको हो त क्यानलको पोर्सन त।
अनि यो कन्स्ट्रक्सन अफ हाइवे फर 1 किलोमिटर लेन्थ
त्यो चाहिँ के हो, डिलिट भएछ है के हो? ल ठिकै छ, पख त्यो अस्ति बनाएको थिएँ। ल ठिकै छ, त्यसको म भोलि थोरै त्यो त्यति
हुँदैन र? हामीसँग टाइम छ के?
हजुर हजुर हजुर
अब यिनीहरू चाहिँ रहेको अरू क्लासमा गर्ने कि टाइम छ कि हामीसँग?
ल ठिकै छ, मैले भन्नु खोजेँ जस्ट यसको केही पनि छैन। र यसको जुन यो हाम्रो जुन पायरको गरेको थियो नि, अब यो हाम्रो यो जुन वेल फाउन्डेसन भयो, वेल फाउन्डेसन भनेको त त्यही सर्कुलर हुने भयो। अब त्यो हाम्रो फाउन्डेसनमा पढेकै कुरा हो। ठिक छ। अब यो जुन पायरको लागि जुन हामीले सेन्टर टु सेन्टर डिस्टेन्स गरेर अनि त्यसको यो सर्कुलर पोर्सन हुने भएर हामीले जुन टाइपको एस्टिमेट गरेका थियौँ त्यही टाइपको एस्टिमेट हुन्छ भनेर। अब ल ठिकै छ, त्यसपछि यो भोलिको क्लासमा हेरौँ ल। हजुर
कति मार्क्सको आउँछ सर यो क्वेशन?
तिमीहरूको 5 देखि 8 मार्क्समा सोध्छ। र तिमीहरूको यो सबै एस्टिमेट गर भनेर होइन नि त, कुनै अब त्यही मेसनरी वर्क या एक्जाभेसन मात्रै भनेर त्यो टपिक छुट्याएर सोध्ने हो कि। त्यही भएर तिमीहरूको दुईटा मात्रै सब टपिकको सोध्छ, त्यस्तो पुरै डिटेलली चाहिँ सोध्दैन। पुरै कम्प्लिट एस्टिमेसन गर्नुपर्ने होइन, तर त्यही
अरूबाट चाहिँ एउटा सोध्ने हो। यो जुन छ नि
यो जुन मेरो पछाडिको यो जुन बाँकी पोर्सनहरू छ नि, यो जुन मैले बाँकी पोर्सनहरू पठाइरहेको छु नि तिमीहरूलाई हो, यो सबैबाट चाहिँ एउटा क्वेसन आउने हो 5 to 8 मार्क्समा। अरू भनेको त्यही अगाडिको त्यो हाम्रो बिल्डिङबाट 10 देखि 12 देखि 15 मार्क्समै भनौँ न, बिल्डिङबाट सोध्छ। र अर्को भनेको त्यही रोड र हाम्रो क्यानलबाट 10 मार्क्सको सोध्छ।
यत्रो पढेर जम्मा 8 मार्क्स रहेछ है, धेरै रहेछ।
यो लास्टको चाहिँ त्यही झ्याउ नै छ। एस्टिमेसन गर्नु पनि धेरै पर्छ नि त, ल सोध्ने चाहिँ एउटा क्वेसन मात्रै सोध्छ। त्यही भएर खासमा हामीलाई पढाउँदा नि जसलाई पढाउँदा नि त्यही लटर पटर गरेर लास्टमा सकाइदिन्थ्यो कि। प्लस अब यो फिजिकली पढाउनु पऱ्यो अरे, अब त्यो फिगरमा तिमीहरूको त्यो 3D इमेजिनेसनै हुँदैन थियो, अनि झन् बुझ्दैन थियो कि। ल ठिकै छ, अब बाँकी भोलि क्लासमा गरौँ न त है।
हुन्छ सर, थ्याङ्क यू सर।
आजको लागि यति नै गरौँ।